Welcome to this presentation. My name is Anatole Deligant, and I will present here the Digital Twin ESRIN project developed at the ESRIN lab over the past 5 months. As a technology demonstrator, Digital Twin ESRIN can be contextualized within the broader Destination Earth program. This program aims at developing a precise digital model of the entire planet. Digital twin precursors are the first step towards this endeavor, prototyping development in selected fields. Our goal was to demonstrate functionalities for the visualization of and interaction with environmental data in an extended reality environment representing a replica of the ESRIN site. This would be made possible by leveraging existing remote sensing data necessary for the 3D modeling of the area of interest. Some of this data comes from the Digital Twin Urban Pilot project from DLR and MineEarth. Lastly, linking this environment with in-situ and external data sources is necessary to provide realistic use cases. The technology we used for development include bleeding-edge versions of the Unity game engine and especially its OpenXR plugin implementation, released in 2021. Two recent VR headsets, the Oculus Quest 2 and the HTC Vive Pro, were used for testing. Our program contains models of the ESRIN site from 2018 and 2021. Agisoft Metashape was used to generate the 2018 model, while DLR and MineEarth provided the 2021 version. The newest one is the most accurate and contains very little artifacts, such as those usually caused by reflective surfaces. This project allowed us to demonstrate several practical functionalities. First is the near real-time link to REST APIs offering air quality and vegetation health data. These APIs are connected to sensors such as the Wearable Mark II sensor. OpenXR also demonstrated its interfacing capabilities, enabling a headset-agnostic experience. Finally, existing game engines, in this case Unity, were shown to be highly capable of developing visualization and interaction capabilities for digital twins. On the left, you can see the 2018 model being loaded while using a VR headset. The user, or player, is able to navigate any part of the campus, including rooftops, through teleportation and snap turn. Previously mentioned capabilities are also present. Here, the AQP sensor. As shown now on the right, the application is also usable without a VR headset. Here, the 2021 model and vegetation health sensors are being showcased. All sensors are located at their approximate real location in ESRIN. With this development framework in place, numerous functionalities and use cases on visualization and interaction can be implemented. They include the visualization of historical data, such as past air quality, Earth observation data, like ground motion data from interferograms, location-based components, especially relevant for augmented reality, or interactive use cases, such as flooding simulations. What these functionalities have in common is the need for data interoperability, as getting the data into a game engine can sometimes be complicated. However, there are several limitations, some inherent to VR. The most visible one is the lack of immersion when navigating photogrammetry models. They especially pale in comparison to video games. One mitigation could be to use an abstracted view of reality through a limited level of detail. Also, VR is still limited in its accessibility, in particular due to the equipment's acquisition cost and the difficulty in sharing content to groups. Lastly, VR is simply not suitable for all types of information, such as text or graphs. This is the end of our presentation. Thank you for listening, and feel free to get in touch if you have any questions.